Alright, hey guys, let's take a look at the derivative of arctangent. So the first thing we probably want to do is kind of think about what arctangent is. It's simply the inverse of the tangent graph, right? So if you think about an inverse, it's where you flip the x and y coordinates. So let's say this point equals 3, 4. It probably doesn't, but let's just say it does. On the arctan graph, it would equate to the point 4, 3. And if you think about the asymptotes on the tan graph, you have asymptotes at pi over 2 and negative pi over 2, as well as other ones, obviously, but I just did this for simplicity. Those asymptotes appear not vertically anymore, but horizontally. So that's kind of the connection between the two. So now let's begin actually doing some math. So y equals the tan inverse of x. And the way we get rid of this tan inverse is we can take the operation of that. So we can take the inverse of this operation. What's the inverse of the inverse? Like the normal thing, right? So what's the inverse of tan inverse? It's just simply tangent. So let's just take the tangent of both sides. So tan y, and if I were to take the tan of tan inverse of x, what does that equal? Just x. From here we can derive, right? Because this is something that we know how to deal with. So the derivative of tangent, you can work it out using quotient rule, or you can kind of commit it to memory. I commit it to memory because it's easier, but it's secant squared, and then dy dx, right? Because the chain rule, you can't forget about this y inside. It's a common mistake. And then derivative of x is dx dx. And I'll try it out now, but in the future, dx dx, what does that equal? It's always 1, right? The same thing divided by the same thing. So from here, we're going to want to figure out, what dy dx is, right? That's the goal. So let's just solve for dy dx ahead of time. And dy dx equals, if we would get dy dx by itself, we would have to divide this over, right? So 1 over secant squared x, okay? And I'm just going to do this right away. It makes it a little bit easier, but secant squared is kind of ugly. So let's just think about what secant squared is, right? It's 1 over cosine squared. So I'm just going to replace that with 1 over cosine squared x. And from here, I can do a little bit more simplifying. This just equals cosine squared of x, right? Do we see how this works? Because when you divide this, if you think about division rules with fractions, this is what it eventually turns out to. So we can simply say that the derivative dy dx has to equal cosine squared. And excuse me, this was a mistake. This should all be y. This should all be y. Sorry for that. Sorry for that little issue. So this should all equal cosine squared of y. But now, we don't really want it in terms of y. We want it in terms of x. So let's think about the geometric triangle stuff that we learned in geometry. So we are given that tan y equals x. So let's figure out, maybe we can use that to figure out what cosine equals by using the legs of our triangle. Tangent of y equals x. Tangent equals opposite over adjacent. So opposite over adjacent has to equal x over 1. So opposite equals x, adjacent equals 1. Pythagorean Theorem to find this, I'll call this c. A squared plus b squared equals c squared. And then we're going to solve for c. So c has to equal the square root of a squared plus b squared. And then we're going to start plugging in our numbers. So c has to equal, and c is the hypotenuse, c has to equal 1 plus x squared, but do not forget the square root. Okay, so that's what c equals. And what we need to figure out is we need to figure out what cosine squared of y is. Cosine, if we recall, is adjacent over hypotenuse. So I'm going to move this out of the way because I'm running out of space. But adjacent over hypotenuse, so we know that cosine of y thus would equal our adjacent over our hypotenuse, which was 1 plus x squared rooted. Okay, so that's what cosine y equals. But we need to figure out what cosine squared of y equals. So we'll just square this bad boy. We'll square it. So just multiply by itself. Multiply 1 by 1, what does that equal? 1. Square root times square root is just the stuff inside. And I'm making another mistake here. This should be squared. So this is what our answer is. dy dx, or the derivative of arctangent, equals 1 over x. Excuse me, another mistake. Whoops. 1 over 1 plus x squared. I hope I helped. And also, just sorry, another addition. If your teachers on your tests might throw a number in here for x, but like let's just say 3. Say they threw in a 3 there. Well, you don't need to fret, right? Because then you just say tan y equals 3x, and we can just throw this 3 here, and then that would end up changing the hypotenuse, but you can kind of work from there. So that's kind of the extent to which your teachers would test you on that. But I hope it helped. Thank you. Bye.